Yeah, hi, this is Ramna Reddy. I just came to introduction about embedded system. So, it is embedded system is widely used in real-time applications. Nowadays, in many ways, it is used. So, it's a vast areas of in embedded domain. So this is the contents available in embedded system basic contents that is introduction about in this PPT these are the contents introduction about the embedded system and also history and also architecture of embedded system applications essential component these are the remaining one these are the contents so let's start what is the embedded system actually an embedded system is a combination of many peripherals and microprocessors and microcontrollers based systems. So in a large systems, like one car, one missile, or one aeroplane, these are the large systems. In that systems, we used number of subsystems. In the subsystems, we used embedded process controllers for development of or for application oriented implementation of that subsystems. So total integrated that subsystem, we make one major system called one car. In car we use a many ways, in aeroplane same thing. So these are the main components are available in embedded system. So these are the main components, that is central processing unit like microprocessor unit, and also one memory, or that memory means RAM and ROM and secondary storage areas. These are the memories and input devices, that is mouse, keyboard, or else another thing. Some other things are there, and also switches. These are the input devices, output devices, monitors, and also LEDs. These are the category of 7 segment displays. These are the category of output devices. Application specific circuits. If suppose we want to use any sensors, real time information getting. So for that purpose, we use the sensors. For the sensors, through the ADCs, we connected to our central processing unit. So for that purpose, we used application specific circuits. Communication interface. We have in real time many communications are available like SPI, I2C, UART, and some more CAN, Milestone 1553. These are the communication interfaces. Ethernet for networking, LAN. These are the main communication interfaces. History. In embedded system in previous years, we in 1970s we used general purpose systems we developed. So after came in coming days, I mean after 1970s, we have implemented step by step processes in embedded way. So in that way, mainly inside the microprocessor many gates are used for development of that processor. That processor means like floating point implementations and resistors, stack pointers. These are all are resistors. These are based on gates we implemented. These embedded systems are used subsystems in a large systems, and also some small applications also we used, that is traffic controlling, and also home appliances. These are the main areas. So let's see application areas. Automotive electronics. In automotive electronics, we have a number of cars available in market. In that cars, we have a many sensors or many controllers. Uh, that purpose we used in automotive like light controllers, fuel indications, and audio and video in car, and brake systems, and also speed indicators, and ECUs, main electronic control units, and nowadays battery cars are available. That cars we control through the I mean we monitored that battery information. These are in that cars, I mean automotive domains. So these are the main areas. And aircraft electronics, these aircraft electronics for black box, and also missiles, and also fin controlling. These are the wings controlling and fuel indications. All are what are the cockpit. These all are areas implemented in embedded domain only. Trains for signal, main signal indications, and many areas in trains, and also telecommunication for telecommunication and networking. I mean, the GPS and GSM. These are the modules main in communication between the end to end. These like for nowadays 5G, 6G. I mean nowadays 4G. These are the uh, generation of networking speed. This depends upon in that one routers and switches and many more applications in telecommunications are available. And another areas are medical equipments, medical systems, X-rays, MRIs, and also CROs are available for indication of health monitoring, heartbeat sensing, and also like um, uh, BP missions. These all areas are in embedded domain. Military applications, also, in missiles for fin controlling and also main system controlling, and all internally various sensors interfacing are there available, either CMOS, TI sensors. These are the many sensors interfacing, and also fin controlling, wings controlling, and also main main missile controlling part, hitting. These all areas used in embedded domain. Authentication, in many in our companies organizations, authentication missions are there through the biometric. So that missions are used in embedded domain. Consumer electronics, many ways, fabrication equipments, small buildings, light controlling, and I mean lifts. These are the areas of embedded applications. So essential components, that means inside one application, we develop major components we used for development of any application. That is microprocessors or DSPs or microcontrollers, These are the main unit for processing of any applications. So actuators. This is performing output task for any, suppose value controlling, and also motor controlling, motor on off. These are the main functionality of activators. Memories, the storage areas, on chip and off chip. Internally microprocessors are available some memories, if suppose needed, we connected to off chip memories. So converted A to deconverts. Already we know, we have a real time scenario, some information, pressure, humidity. These are the temperature. These are the requirements we get. So we use it through the we monitored the temperature data, humidity data through AD to D converter. I mean analog to digital. That digital connected to our microprocessor. Same. If suppose we have a one digital data, that one we connected to analog. Suppose we output. So for that purpose, we use analog to digital, digital to analog sensors. We have a real number of real-time sensors, medical equipments, electronics, basic electronics, and also military, automotive. These are the main any areas we use the some sensors like temperature, humidity, pressure, like that. LVD, I mean position sensor, like that. Communication path and interacting environment. That communication path means we have, I mean, suppose we have a AD2D or memory with respect to microprocessor, microcontroller connection. We have some internal onboard communication needed, like UART, I2C, SPI. These are the communication areas. Many more. These are the embedded system overview. That is, once in any application, this is a little bit overview. That is structure of that. We sense data, that sense given to nlog, the nlog data. That nlog data converted to processor. That processor needs digital data. That is A to D converter we used. So nlog to digital data, it's converted, then it's given to processor. Again, processor, some processing is done, then it is converted to digital to analog data. That analog data we given to output, that like actuators. So inside memory, we get the data from sensors. That sensor data we stored in some memory area. That is used in memory. So essential considerations: response time. Suppose if you given, I mean, if you given the output, so we motor on, let's say example, we motor on, that motor will give feedback of positions like that. That is which time they given response. So area, cost, and low power consumption. Cost is a major factor for embedded, less cost application development. And low power. Low power means it's battery based applications we develop. So battery needs 3.35 volts, or some time it's needed. So we consume some low, we consume some power, depends upon whenever unnecessary components are not used off that areas like that. So fault tolerance: if in real time applications, if any faults happen, then we correct it, that one. General characteristics of embedded system, that is perform a single task. If suppose traffic controlling, let's say example, then it's control the traffic through light, red, green, like that. So these are the single task perform, and increasingly high performance and real time constraints. That means in many application in missiles and also automotive, real time constraints are there. So for the high performance, high performance needed, power, cost, reliability are the important consideration, as already we know. Hardware and software systems, these are the main software is used for developing of any application with some features and flexibilities. Hardware, process and memory, etc. Standalone embedded system, we have a let's say example, this is the standalone embedded system. For it is used for single task. Let's say we get the information from sensor, that sensor data we displayed through LCD, or we LED on, or TV remote system, RF based systems. This is a single task, specific task we implemented in standalone. Let's say real time systems. So here the soft real time and hard real time. Soft real time means it is not a uh, not necessary for time, I mean, strict timing. Strict timing means suppose, let's say video games, it is if some buffering happen. If suppose if buffering happen, not a problem. In hard real time, in missiles, some hitting is there. So in that time, time construction, let's say in 2 seconds we hit the that target. But here, if any deviations happen, I mean, that system is failure. So this is the difference of soft real time and hard real time. And networking, in our many systems, networking implementation, that is information sharing, like that. And I mean, PDA, mobile systems in video games, in like that. So that is a main digital equipments, the main importance of embedded software and embedded process. So these are the factors. I mean, in nowadays, hundreds of microprocessors used in one systems for for using of one big system. Then in subsystems we are implemented through embedded process, that explain in recently newer times. So nowadays, embedded system is a very crucial part in real time scenarios, simple tasks and technologies. Thank you. Is there any doubts? Please let me know.